So we talk about the motions of the earth. Here I have placed two GIFs. So the earth is constantly in motion, and there are principally two types of motion of the earth. One is the rotation of the earth and the other is the revolution of the earth. So rotation of the earth is basically this: the earth is revolving on its rotating on its axis, and it makes one rotation in 24 hours, that we all know. 24 hours makes a day. So, and another important thing is that earth is not rotating in a vertical position. That is, its axis is not like this, it is like this. It is tilted at an angle of 23.5 degrees from the straight line. So it is rotating like this from west to east. Similarly, like it has been shown in this GIF. And additional information I have given that it has is the rotation. The speed of rotation is approximately 1038 miles per hour. It is at the equator. Now, important point to notice is that you might be wondering that I have mentioned that it is decreasing to zero at the poles. That is because if we consider a person standing here and here, the speed of so at the equator, what is happening is speed will only be there. We can only tell that speed exists when actual motion forward or backward is taking place. So if a person is standing here, or whatever object, whatever building or whatever infrastructure piece we have here, so it is slowly moving ahead based on an observer's perspective. So it is moving ahead with a certain speed. But as we go towards the poles, we can see that here, if a person is here on the poles, if the person is here on the pole, he is not moving ahead, he is just rotating in circle. Obviously the earth is large enough that we don't feel the motion, so we are not revolving in circles at that particular moment of time. But actually the speed of rotation, because the person or the point is constant here, it is not moving forward or backward, the speed decreases to zero. Another explanation which we will further be discussing in another topic known as Coriolis force, which becomes very important, is that we can also a little complicated. We can also think that this circumference, this boundary of the earth is much larger than this. So since the earth is not getting dismantled, if the pole was also having a speed same as this, so the pole would move somewhere somewhat forward than the equator. So the equator has to cover a larger distance in the same time, so that this line stays constant. So if this line has to stay constant, and if the speed is the same for all, then it will be, the earth will get distorted, and a person like standing here, he will be basically cut into several parts. So since this point has to travel 360 degrees in 24 hours, so this distance as compared to the top of the north pole or the south pole, so that is why the speed here is zero. And as we go down, the speed of rotation increases, so that the point they, after rotation, after how many whatever number of rotations they exist or they are placed, they don't move apart from each other. So that is why we have the earth, the rotation speed of the earth, it is maximum at the equator and it slowly decreases to zero at the poles. Okay, now we have discussed the first motion, that is rotation. The second motion is revolution. Revolution means that it is orbiting around the sun in an elliptical path, not in a, that is an important point to note, in an elliptical orbit and not a circular orbit. So it takes around approximately 365 days, but the actual length is, the actual time is 365 days 6 hours 9 minutes. So you see that if we forget about this 6 hours, so we are every year we are missing out, we are neglecting an additional 6 hours. So how do we manage this addition? Where do we adjust this 6 hours? That is why, since 6 into 4 is equal to 24, so every fourth year is a leap year. So that is why February has 29 days every leap year. So in that case, when we have 366 days, so, or in simple terms, 365, we have then 365, then the next year is 365, then we have fourth year as 366. So we had minus 6 hours, minus 6 hours, so that the combined loss of 24 hours in the 4 years is compensated by 1 day, the entire 24 hours, entire 1 day. So this is the concept behind the leap year. Another point to note here is I talked about an elliptical orbit. So what do I exactly mean by an elliptical orbit is that if I have a sun, this very basic childish drawing, but and this we have as the earth. So the rotational orbit, those of you who have not studied ellipses in 12th, 11th and 12th mathematics, they might not be aware of this term, but fortunately I'm an engineer, so basically like a circle has only one focus, an ellipse has two foci. So there's no need to go into the depth of mathematics, we are not studying engineering here. So this means that the earth's distance from the sun continuously varies as it revolves around the sun. So here we can say that it is nearest to the sun, and here it is, when the earth comes here, it is farthest from the sun. And another concept you can remember, that obviously when the earth is closest to the sun, the gravitational force exerted is inversely proportional to the radius, which means that the closer the body is to the sun, so the more gravitational force will be there, and its speed of movement, its speed of revolution will also be faster. So this was the thing. And another point which we had discussed in the last previous video was that the distance between earth and sun is equal to 1 astronomical unit, which is just for convenience because it is some lot of decimals and lot of different numbers are involved, so we conveniently for multiple distances we use 1 astronomical unit. So this basically is responsible, rotation is basically responsible uh, for the days and nights, and this is basically responsible for the seasons. So moving on,